All right, and then elimination. I'm not going to go over the first one, but I'll use it as kind of an example here. With elimination, we want to, this is a little different. We don't need a variable by itself. So we just need everything lined up. Now, if it's not lined up, and when you look at this, I'm hoping you're thinking, number 8, not lined up. Not lined up, right? The number, the equal sign's in the wrong spot. So in that case, you'd have to rearrange, right? You'd probably want to move the 4y and the negative 5x over here. So that way then you have negative 1 equals, and then what was it? It would be plus 5x because we're crossing the equal sign, and then a minus 4y, and then you're all lined up. And then you could go about your business as you see fit. Okay, but everything else is lined up. And what I mean by lined up is x on x, y on y, and then number on number. And the equal sign's in the same spot. X on x, y on y, number in the same spot. Same thing here. X on x, y on y, number in the same spot. And with that rearranging that we did, and let me show you that again real quick. Again, it would be, even though it's it looks a little out of whack, again, it's, if I cross this out, it's number on number, x on x, y on y. Okay, so that one you'd rearrange, but after that you can solve. The first one, once you get it so that it is lined up, basically just you either can add right away or you're going to have to make an adjustment. And for number 1, you could add right away. And basically the way to check that is just look down the rows. Like for example, these ones right here. One's a 7y, one's a 10y. Now they are both positive and negative. However, they won't cancel each other out because they're not the same number. If this was a positive 10, we'd be good to go. But that doesn't work. However, right here, you have exactly what you need. Both 7x's, one is positive, one is negative, and so you could add right away. These would cancel. That's the elimination, and you'd be good to go. Okay? So I'm not going to do that one. Now with 6 and 7, you're going to have to multiply times something to make the elimination happen. Okay, and what I would do is just check, is there a way, to make 7 into 14 pretty easily? Yeah, I could multiply, right? Now, they're both positive, so you'd want to make one negative. So you have 2 options. You could multiply this one times negative 1, and this one times 2. And you can multiply both equations. That's the one thing we didn't get a chance to talk about before I left. You could multiply both equations, but in this case, it's not really necessary. What I think I would do is just multiply this whole thing times negative 2. And then watch what happens. 14x plus 4y equals 12. We didn't change that one. That's horrible. Sorry, folks. And then when we multiply, it's negative 14x. There's our cancellation. There's our elimination. Negative 16y. And then negative 48. And then you'd actually be able to, let me actually try and write that again, so it doesn't look so bad. There we go. Yeah, I would just multiply that times negative 2. You're allowed to do that. You can do a number and make it negative. As long as you get this. As long as you get the same number, opposite signs, you're good to go. Okay, now I'm going to show you this whole example, or at least as much as I can here, as quickly as I can. So we want to eliminate. Everything's lined up. Awesome. And I look here and I say, okay, they're both positive, so at the very least, I'm going to have to make one negative, right? But there's not really an easy way to multiply 4 to get to 7. It's going to be a decimal or a fraction. I don't want to do that. All right. So now I check here. Both negative again. I'm going to have to switch the signs on one of them. However, this 2 is not easy. 2 times what is 9? What could I, take 2 times to bump it up to 9? And again, you're going to have a decimal. So I wanted to show you this example because what we're actually going to have to do, it doesn't happen often, but what we're going to have to do is multiply both equations, okay? So in red, and by the way, this will work for any, here, hold on a second. That didn't work at all. We can actually do this for any set of equations. Any set of systems like this, we could multiply both. And what I'm going to do is I'm going to multiply this one times 7. And I'm going to multiply this one times -4. Here's why. So I'm focusing on canceling the x's. And in red, when I distribute, I'm going to end up with 28x. The numbers are going to get a little big. Minus 14y. And then 7 times 14. Off the top of my head, I couldn't tell you. So let me do it real quick. 98. So yeah, your numbers do get a little big. Oops. There we go. All right. In blue, we would have -28x because I'm going to distribute this. Distribute this plus, what is that, 36? Yeah. And look at that. We now can cancel the 28x and the -28x. We add those together, they cancel. 36 minus 14, essentially, 22y. We're adding -14 to 36. And this would be -198. We would divide by 22. And the answer is 9. I guess we ought to check that, make sure that we're all good. What is it for number 7? Number 7. Oh, it's -9. Oh, -9. Duh. Negative. I just missed the negative. Oh, come on. There we go. Gee whiz. Okay. -9. And so in that case, you kind of have to do that. Now, you could do it for the y, you could do it for the x, but it is possible for really any of these. If you're not really sure, just pick one of your variables, x or y, and just multiply times the opposite number. Like I could have, and you guys can go back and pause and check that out, what I just did. You could also, gosh, this is not, there we go. You could have instead multiplied this one times 9 and this one times, actually let's do a -9 and 2 and watch what happens when I do that. It would be -36x plus 18y equals, I'm not going to do that just so you guys can see, 14x minus 18y. And then when you go to add, this would cancel. Okay, so hopefully that helped.